Hi, today we are going to bring some of the components available in Open Source Cloud together, and we are going to build our own content preparation pipeline for VOD streaming. We have in this picture we will use one of the components or one of the open web services in Open Source Cloud for doing video transcoding. It's the SVT Encore. We will use an open web service for generating subtitles utilizing OpenAI Whisper 1 and that model. So this is an open source project available. And then we will use the Shaka packager developed by Google, which is an open source packager for creating VOD streaming packages so they can be distributed online. And in addition to that, we will use some storage buckets here on top of Minio server. And then the part that will sort of drive this process automatically is this repository called Open Media Supply Orchestrator. And this media orchestrator will be running as a web runner in Open Source Cloud. So everything will be deployed in Open Source Cloud when we are done. So the first thing we are going to do is to create the storage buckets, and for that we will go to Open Source Cloud, and we will find the Minio service. We can create a storage that we will call YouTube. And we need to give a username. We can call it root, and then we will have to enter a password. Right, so of course I could write a not so safe password here in clear text, but that's not the recommended way. So the recommended way is that we store this password in a secret. So let's call it YouTube Minio password, and we can, for the sake of this, make a really simple password. So we can create this secret. We can go back and create this Minio server. And we can select this secret. Wait a little while. Just now when we look at the instance parameters here, you see that we don't expose the actual password. All right, now it's up and running. And then we're going to create buckets on this server. And for that we will use the client, the Minio client that we have installed. But we can start by creating an alias here. YouTube. Then we will copy this URL. And then the password. We can check whether we can access it. Right, so now let's create 3 buckets. ABR subs. Call that origin. Now we have 3 buckets. So we are done with that. The next thing we will do is create this subtitle generator service. And this service we will need to create some secrets for. We will need to have an OpenAI key. We call that OpenAI key. Right, so now we have a secret for that. Then we can create it. Media supply. Yeah, that's a good name. Not that one, this one. And then the menu user, the menu password. We can leave region out, and then we will have the URL to the mini server that we created, and that's it. I can press create. Now it's up and running. You can check that it's online. Great. So that was that. Now we created the storages, we created the subtitle generator, and now let's move on and create the transcoder, the SVT Encore transcoder. So let's look that up. We create some secrets. Menu user, menu password, call it media supply. We choose those secrets. A session token we can leave out for now. Region we don't need. And the endpoint is the endpoint to the menu server. Press create and we'll wait for it to start. It's up and running. We can check it's online. Yes, it is. Perfect. So now we have created the transcoder. So next thing we're going to do is to configure the Shaka packager. The Shaka packager is not a type of service. It's not a job that is running. Sorry, it's not an instance that is running. It's actually jobs. So we only actually need to configure this with the password. Great. I think that's it. And as you see from this diagram, what we will do is that basically when a file is uploaded to this input bucket, it will trigger an event that this media supply orchestrator will act upon. It will ask the subtitle generator to transcribe it and create subtitles, and it will request transcoding from the SVT Encore transcoder, and then it will create a Shaka package job to create this VOD package. So, and this media supply orchestrator is available as well. It's open source. It's actually here. So now we have a few options here. We could either fork this this repository, since it's public, and modify it to our own liking, or we could just take it straight off and run it and deploy it as a web runner. But before we deploy it as a web runner, we need to have a way to store the configuration for this. So if we look here, it needs some environment variable sets or some configuration sets. We need to configure the address to these components and some credentials. So in order to do that, we will create another service, not in this picture, the application configuration service. And for that service, we need to store the data somewhere. So we'll create a val key first. So let's do that first. So now we just create a val key. We copy this address, and then we go to application config service. media supply, and here we enter the Redis URL like that. Right, so now we have a configuration service that this web runner can use to get the configuration values. So the web runner, what it does, you point a GitHub repository, it downloads the code, and it starts it up, and then it runs as a service. Right, so now it's up and running. We can open it up, and then we can start adding some configuration. First thing is the S3 access key ID, which was a root. And then we have the S3 secret access key, which was, in our case, a secret. I think that was the right secret. And then we have the menu server URL. And then we have the Encore URL. And then we have the subtitle generator URL. Okay, that's it, I think. There are a few things we need to do to be able to deploy this web runner. Is that we need GitHub token first. I'm going to settings. We will go to developer settings and create a fine-grained token. We can call it YouTube demo. Public repository read-only will be sufficient, and we can generate this. I will copy it, and then we another thing we need to do is that we need to create an OSC token. And the OSC token is the API token here. Right, now we have those ready. We can give this name media supply, and then we need the URL to this repository. We will use the GitHub token, OSC token, and the name of the configuration service. And then we press create. This will now download the repository and start this service up. Right, so we can see the logs. We can start by uploading a file. We will upload this file, this OSC reel. But before we do that, we will upload a text file which contains some entity data for the subtitle generator. So for the transcription to be more correct, we have prepared it with some domain specific keywords. So we will copy this one first. and then we will copy the actual video. See if we see something in the logs here. Okay, this should not be necessary, but yeah, just to rule that out, let's enter that in clear text here, and then restart this. Okay, listening for notifications. Try again. Now, so it started transcription, and it started transcoding. And we can actually see what we have got on this ABR subs bucket. So we have a folder here. Where we have the subtitle file. So now we're waiting for the transcoding to be completed. So if we look again here in this folder, we should now have a lot of other files here. So here are the ABR files, as we call it, each of the individual bitrate steps in the ladder. All tasks done. Perfect. Now let's see if we can try and watch this file. But to do that, we need to anonymous set download YouTube origin. So now I can access it. So let's go to our web player, and here we will have the URL, origin, name of the bucket, index.m38 for HLS.
Welcome to Eyevinn Open Source Cloud, your gateway to a world of open web services. Imagine a cloud service where every component is built.
Now it's subtitles as well.
Eyevinn Open Source Cloud.
All right, so to summarize what we have done, we have first set up the components that the open web services that we want to use, the subtitle generator, the ABR transcoder, and the VOD packager. And then we deploy this media supply orchestrator as a web runner, so running here continuously and listening for events from this bucket. Then that will in turn create a transcription job, ABR transcoding, and a packaging job. And the result is what you just saw. So we have built our own media supply chain in open source cloud.